Hi guys, some of you have some doubts about how to solve the first problem about diffraction in the homework. So I will explain it, okay? So, well, let's focus on the experiment that I did, the demonstration, and let's use this. Let's focus here, okay? Which is what we want to, it's where everything happened, okay? Between the grading and the screen, okay? In the picture in the left, it's we're watching it from above, okay? The screen and the grading, okay? And of course in the screen there's, in this case, there's 5 points, I think. Okay, so well, this all of these graphics you saw here are actually diagrams about this thing. It's the grading and the screen, okay? The grading and the screen. So let's have a look. Here I was drawing. Let's say that this is the grading and this is the screen. Of course, we're looking them from above, okay? And let's have a look. What are all of these things inside the equation? So as you saw, well, the laser, the beam of the laser comes here, goes through the grading, and then we have all of these dots over there, okay? So, well, first D is the distance between the little, let's call it, holes that we have in this grading, okay? The little apertures that we have there. If you see it here, this is a two slit. Just these are here. We have just two slits, and it's the distance between them. Okay, when we have more than two slits, a lot of them, then we can see very clear dots. Okay, when it's just two, we have the same effect, but actually it's not too clear. Maybe something like this. Okay, there's not a clear distance between dots. That's why it's better to use grids with a lot of little slits. Okay, so but that's the distance between slits. In this case, for example, we know that for the first slit there's 100 for the first gradient. Sorry, there's 100 lines per millimeter. Okay, that means that 100 slits per millimeter. Okay, how can we calculate the distance? So divide 1 in 100. Okay, 1, oops, sorry, 1 in 100. That's gonna be the distance, and the distance is gonna be in millimeters. Okay. Okay. Then the way how can we relate the gradient with the dots? It's using right triangles. Okay, so let's sorry. I don't know what happened there. There we go. Okay. So I was saying that the way how can we relate it? It's with right triangles. Okay. So let's say that we have one side of the triangle that goes from the grid, where is the little window, the little grading. That's one side. The other side is gonna be between the dot in the center and the other dots. But in this case, let's talk about the first dot above the center. And the hypotenuse, sorry about my drawing, it's gonna be that one, of course. Okay, so the angle, this angle little here, is this one. Okay, that's theta. What is the distance between the gradient and the screen? I gave you there. I think I wrote it as capital D, right? Let's have a look. Oh, no, I didn't. That well, distance between the gradient and the screen is 30 centimeters. Okay, so that's big D. And the distance between the dot in the center and the first dot is y. Okay. And what is m? M is the location of the dot in relation with the one in the center. In this case, it's, of course, here's the dot in the center. It's one position. It's the next dot next to it. So in this case, m is equal to 1. Okay. If we would in the problem, well, I give you the distance between the dot in the center and the first one in the left, it was. Okay, so in that case, m is 1. I could have measured the distance between the dot in the center and the second one. Okay, and in that case, m would have been equal to 2. Okay, same under here under the center. This little dot there, m is 1, and here dot is 2. Okay, well, in this case it's -1 and -2. Okay, but at the end you're gonna have the same result. Okay, it's just how many dots there are from the one in the center. Okay, so great. I told you that there's a D and there's a Y there, but they're not in this equation. Why? How can they be useful? Of course, to find theta. Okay, you know how to solve that using Pythagoras. You can find the value of the hypotenuse, and then you know that sine of the angle, it's equal to the opposite side, in this case E, divided by the hypotenuse. Okay, hypotenuse, it's equal to one side square plus the other one squared. Okay, and that's it. You just need to be aware that, yeah, in this case m is 1, because in the screen here I measure the distance between these 2 points over there, the center and the one in the left.